think I was in your seat about 4 years ago, before I just sort of stumbled on to this idea. Met my co-founder and current business partner over at Haas Business School. I was a scientist up on the hill at Lawrence Berkeley National Labs. I went to this sort of mixer where they sort of link up entrepreneurship MBAs along with scientists, and the idea was that over pizza and beers that we could sort of come together and come up with some ideas that might be disruptive commercially. And so before I sort of dive into what I did, sort of give you a little background on myself. I was a biophysics PhD student interested in learning microscopy and computer vision. The two people depicted here are my advisors. I was again a PhD candidate at Scripps Research Institute. I thought I was going to be in the academic sector for the rest of my life. That was until I finished. And so I graduated in 2009, and I was deciding between doing a postdoc in academia versus sort of jumping into the industry. And I was particularly interested in a field called circulating tumor cells. And what that really entails is these are rare cancer cells that use the bloodstream as a superhighway of sorts to sort of colonize other critical organs. So that's how your cancer metastasizes, and that's what ultimately leads to one's death. I was fascinated scientifically. I wanted to research these cells in more detail. However, there was a strong commercial aspect to them in the sense that we could potentially use these cells as a sort of a tool for understanding how diseases sort of progress. And so I was debating between the two. My advisors were actually very supportive of me sort of venturing into the commercial space. They had not started companies, but had consulted for several startups and were very strong promoters for sort of making the jump from academia into industry. However, I decided to do a postdoc. I did a short stint at Harvard. I pitched my idea, and my advisors at Harvard told me that I should move out west and start up an idea. Basically, idea of looking at circulating tumor cells for diagnostic purposes. However, I did a little pit stop at Lawrence Berkeley. I had the opportunity to work semi-independently. At the time, the economy was pretty bad. There was a Obama stimulus plan, and there was a great opportunity for me to do this sort of, I guess, preclinical research on the government's dime. So I took that opportunity. But about a year and a half in, again, I decided that I was more interested in, again, taking this idea and commercializing it without, again, having very little experience in the commercial space. And then I met up with my business partner, took this class called Lean Launchpad, which was spearheaded by this gentleman here, Steve Blank, who's a very reputable entrepreneur, as well as a sort of strong proponent of the Lean Launchpad model. I'm not sure if any of you guys are familiar, but he's a well-known individual on campus, and he's currently one of our earliest investors. So in 2012, we did this 10-week-long class. We did 100 customer interviews. I had no idea what the regulatory framework looked like in the US or in the world. I had zero clue. I was just a pure scientist. But during this 10-week class, one of the big lessons that were sort of, again, pounded into us, if you will, was that we needed to understand our customers. We needed to understand the regulatory framework. We needed to really understand the needs of the field before embarking on a commercial enterprise. And that still holds true 4 years after starting the company. So we were, I guess when we first started, we were 5 individuals. We're 15 now. 2 of our founding team had to stop working for us because they needed to get paid. But Brian and I, depicted in the middle, we basically took no salary for 2 years and really bootstrapped our way into financing, into our first customer sale, if you will. And I'll sort of tell you a little bit more about that later on. But yeah, I had to quit my job for patent reasons. We wanted to own the patent and the IP. I love the UC Berkeley ecosystem, but the investors did not like our patents tied up to an academic institution. And I can tell you a little bit more offline about that if you're interested. But I did quit my job. We incorporated, we released the 5-foot bench through this QB3, or Quantitative Biosciences Initiative, brought out through the UC Berkeley system. We were just 2 for the longest time. We're 15 now. We raised enough capital to get us going. We just launched our first product. We're based out of San Francisco, Mission Bay, right next to the ballpark. But and I guess what you guys are maybe interested in is sort of the regulatory framework. So again, I had 0 clue on where to start. In fact, when I first started, I was like, where do I start? What are the rules? What can I do? What can I not do? And it turns out this was a lot easier. After several hours of Googling, as well as some of these initial conversations via just telecom, and what we did was basically cold called certain individuals that were affiliated within the sort of the similar sector areas. And 9 out of 10 times they weren't interested in speaking with us, but 1 out of 10 they were actually quite open. And so we actually had in-depth conversations. We didn't pay them. We just played the student card. We're students. We're trying to gather information for this class. And believe it or not, we've had a lot of assistance from individuals who just wanted to spend 20 minutes at a time just describing some of their own experience in regards to the sort of the regulatory framework that they had to sort of investigate. But in the sort of the clinical diagnostic space in which we're operating, and we're specifically looking at patient blood samples and making treatment decisions, we can sort of summarize that in a nutshell. There are 3 major categories: research use only, or investigational use only. And I'll describe what those are. Lab developed tests, or CLIA certified, which is the regulatory framework that's in charge of dictating whether or not your test is appropriate for the LDT designation. And then finally, the FDA regulated category, the in vitro diagnostics. The last category is reimbursed, sort of the holy grail of where all the diagnostics companies want to eventually end up. I can go a little bit more in detail about what these means, but research use only is sort of like the wild, wild west. It's not really regulated. The way that I describe it is sort of products that you see as seen on TV, right? They make all these claims, grow back your hair, clear up your acne, and they have some very compelling value propositions, or at least that's what it appears, but it's really more marketing. However, unlike sort of as seen on TV kind of monikers, in the research space, this is actually a very important sector. This allows us to innovate, test out ideas, and potentially get people to pay for these ideas. And for a startup company, that's actually really, really important, right? You're cash poor, you want to create a device or a platform, something that someone is going to value. And this is a great way for sort of getting started. The second one is lab developed tests. So let's say you refine your idea, you created your medical device or diagnostic platform, and now you want to actually start looking at patient samples and maybe start making sort of like sequencing-based information available to your patients or your customers. Is anyone familiar with Theranos and Elizabeth Holmes? Okay, great. So they're in this middle category. And in all honesty, the regulatory network, or the CLIA, the Clinical Laboratory Improvement Amendments, it's still very, there's only like 2 inspectors on the West Coast. We like to think that it's heavily regulated, but anyone with a couple $100,000, some equipment that has been certified could get this designation. It's just a matter of spending your time and putting together a protocol, basically. But it's actually not that difficult to get certified. And so I'll give you a little bit more sort of background on that a little bit later on. And then finally, the IVD. This is when a doctor can actually prescribe this test, right? And a patient will use this test. Let's say, which drug do I have to take for my type of cancer, right? And then insurance companies will reimburse you, right? And you could actually charge it at any rate. Okay? And this is regulated by the FDA, right? And this is sort of the major leagues. However, The drawback is time and money. It sort of leads me to the next sort of slides. Basic research on the very far left, preclinical development as the next phase. That's really research use only. Okay? And you can actually put CLIA or lab developed tests in that category as well. And so in people in my sector, in the biotech sector, typically start off creating sort of the initial framework or the initial platform to get it validated by other users, right? And potentially get paid for it. And as you get better, as you refine the technology and you're confident that it could actually make clinical decisions, right, reproducibly, it goes into the preclinical development. This is where you're going to actually get patient samples, work with hospitals like UCSF and Stanford, and you'll actually start to develop this test with other sort of like-minded folks who are maybe more clinically facing. And after that, and if your technology holds true and there's clear benefit, you may start to apply to get approval by the FDA, with the ultimate goal of being in this sort of reimbursable catalog. Right? I won't go into too much of the details, but you're probably very familiar with this story, Elizabeth Holmes. Great idea, pinprick, it's going to diagnose a myriad of diseases. She raised billions of dollars, great advisory team, yet they weren't FDA approved. They were actually only CLIA certified. And I just mentioned to you before, if you have a few $100,000, some equipment that has been certified by an outside technician, you could get CLIA certified pretty quickly. Okay. Now, CLIA certification doesn't necessarily mean that your tests will actually provide any meaningful information back to you. All it guarantees is that it just provides sort of confidence that your test was done the same way, using certified equipment. That's it. All right. What you do with the data is completely up to you. And there's no guarantee that data is going to be relevant. Okay. Who's heard of 23andMe? All right. Foundation medicine. That's probably a harder one. Well, it turns out 23andMe and Foundation Medicine are also just CLIA certified. Okay. Now, unfortunately for Elizabeth Holmes at Theranos, I think the fact that she drew a lot of attention to herself, the fact that she raised billions of dollars, had this compelling story, without any published material, scientific evidence that her test was actually working, created a lot of issue, at least in the public sort of domain. Her tests, again, at least based on the CLIA certification, was done using the same sort of equipment, certified equipment. Again, their test results were not guaranteed. Yet the fact that she drew so much attention into the industry actually hurts companies like ours, right? Because it brings sort of more regulatory eyes to this, what we feel like is sort of the wild, wild west, which fosters innovations, which allows companies like us to rapidly innovate, right? Get feedback, right? Change our models, right? Without being shut down by CLIA or the FDA. Right? But again, Foundation Medicine is sort of the clinically facing arm. Think of it as 23andMe for cancer, right? But these are all CLIA certified, and their tests as well. You got to take it with their grain of salt, right? The results from these tests, right, are not set in stone. They just tell you that the tests were done in the same way. That's all what CLIA means. Right? So until they get approval from the FDA as an IVD, as a reimbursable test, really, you're basically banking on hope. And that being said, the science, the underlying science here, usually containing next generation sequencing, is quite robust, right? But it hasn't been validated in this large scale clinical trial. So with that, we set out at XCELL Bio to create what we thought initially as a blood-based test. But instead, what we've done is create a sort of what you see here, an incubator, if you will, that will actually grow up patients' cancer cells individually, right? And this is a tool that we developed with the goal of ultimately entering into the clinical diagnostic space. However, again, being cash-strapped, and the fact that we had paying customers who just wanted to use the system for their own research, we were able to not only sustain ourselves, but raise Series A to do the thing that we really wanted to build, which was this diagnostics platform.
And so I actually run a $30 million program with capital from JP Morgan Chase. And what we do is every year we identify a problem facing Americans. We ask for companies to apply, and then we invest about $250,000 in each of the companies and then work very closely with them for about a year to help them grow and scale. Typically the companies that are working with us are kind of at the same stages like where James is, in their life cycle. They've got a product to market, so they're out in the market actually helping consumers save, maybe extending credit, they're doing something. And what we really focus on is helping them grow. And in the United States, the regulatory regime in financial services is very complicated. And so we kind of help these guys navigate it. It's also overlaid by a degree of political activities, I'd say, and over like how those regulations are interpreted, how they evolve, what's allowed and disallowed. And so to a degree, we help companies kind of navigate that space. And so I think, in the financial services industry, it's interesting because it sounds like it's the exact opposite of the nuclear industry, where you have one regulator. To give you an example, can anyone just name one financial services regulator? The IRS, okay. SEC.
That was mine.
In the UK, we have the FCA.
FCA. Like the United States, though. FCA, that's a great one. There's just one. Okay. In the US, see when you walk into a bank. FDIC. They oversee the monetary supply in the country. Treasury, but Federal Reserve. These are just like some of them. That's just a handful. That actually doesn't cover the regulator for consumer financial products, which is CFPB. It was created after the financial crisis because the regulatory regime in the United States was seen as being insufficiently robust to protect the consumers. So the US government created another regulator. It just oversees financial services consumer financial services products. That's at the federal level. There's like a dozen other ones I could name. Each state has a financial services regulator. If you were offering a financial services on this property, so University of California, you would have a different set of rules than if you cross the street over into Berkeley. There's probably a different set of rules in certain financial transactions in Berkeley than there is next door to it in the next city over. In San Francisco, which is a different county. It's an incredibly complex system that's overlaid with a lot of different nuance. And to a degree, that regulatory system tends to protect incumbent players in the same way that really regulated industries do in any field, and make it very difficult for new entrants to come in with new products. Oftentimes products have to be are prescriptive in kind of what they can do, how they can function. And the reason that this is the case in financial services is because the government is trying to protect the money supply. States are trying to protect their citizens from usury, from getting from the mob coming and offering them loans and breaking kneecaps they're not going to pay them back. Cities have an interest in making sure that people are paid fairly, and all of those people are interested in getting taxes, making sure that terrorists aren't using the financial service industry, people aren't laundering money, all sorts of stuff, right? And so because of that complexity, it's very difficult for early stage companies, really companies of all sizes, to kind of navigate that and figure out what they can and can't do. And so that's where we kind of come in. And I think as an organization, we really try to focus on helping companies understand exactly the problems that they're facing, or the challenges and find the resources to do that. And unfortunately, that often means that they have to spend a decent amount of capital to do that. So if you think about startups, if you're familiar, if I had to ask some of the startups, you probably would think, maybe Square would be, or PayPal, Stripe, SoFi. These are actually pretty big business. Half of those are publicly traded companies, but even SoFi is a multi-billion-dollar company with a tiny share of the student loan market in this country. And so it's very difficult to innovate in that space, and a lot of we just kind of try to focus on how we can do that, and with the goal of finding products that can help consumers. So actually, I think this is a really interesting discussion. You often, when in our field, We spend a lot of time trying to help regulators understand what's happening in technology, and helping entrepreneurs understand what regulators are thinking and kind of how to influence that process, because there is a lot of opacity, and just it's a very gray area generally. And so it's interesting to hear in other fields where there is more binary outcomes of like good or bad, illegal or legal, kind of how a regulator thinks about that. But for the financial service industry, as you're kind of thinking about it, it is like the exact opposite. It's very, very unclear. And how we work with regulators, honestly, because of that lack of clarity, is to often try to influence what's allowed and not allowed, and to try to influence a policy agenda in the country on how that regulation is interpreted by financial institutions. So an example, maybe probably the biggest company in our portfolio is a company called Digit, which is an automated savings application. You basically hook it up to your checking account. It looks for money you might not miss and sweeps it out of your account and into a Digit savings account and slowly builds savings for you. Digit is saving hundreds of millions of dollars a year for consumers, and they have hundreds of thousands of customers, a very fast-growing company. But even that really simple transaction involves, county, state, federal regulators. It involves them constantly talking to larger financial institutions and striking partnerships, getting those financial institutions comfortable with what they're doing, and constantly trying to figure out how to change the product as it grows to respond to kind of a changing dynamic.
It's weird sitting here and coming from Google at a panel about highly regulated industries. Google is a software company and a web product, and most of our business is lives in the wild west of the online world. So I can't. But I work in kind of a very small field. It turns out, like a couple of web companies, if you're big and you want to show that you've made it, you have an aerospace project. Facebook has that new drone that they just showed off a few days ago. Amazon has cargo operations as well as Amazon Prime, and we have a couple projects out at a place called Google X. Google X is it's a moonshot factory, what marketers call it. I'll break it down. Essentially, it's a place designed to, grab top talent like James and plug in all these other kinds of insight into them as fast as possible. So I'm a product counsel. I'm a lawyer by training. I used to fight patents in East Texas, and then I heard about some kind of crazy thing happening in some red brick building, and I figured I could help. And so I hop from project to project, and I can advise them really quickly on everything from aviation regulation to export control to products liability, patents, kind of like the one-stop shop. And in some sense, I'm kind of like the legal first responder. I show up, I solve basic legal problems, I call in specialists when I need them, and then I move to the next project. And so, inside this X factory, I spend my time on aviation, but from a broad perspective, we look for cool technology used in a different way to solve big problems. We don't have an industry focus. So in our history, we've done things like, to James' point, we've done stuff in health sciences, medical devices, we have consumer hardware, renewable energy, maritime engineering, civil engineering, what else? And then we have self-driving cars, and then we have my aviation projects. And the broad idea behind these things is to test technical assumptions and fail, but fail really fast and without consequences. So we spend a lot of time kind of, really working over ideas to see if the technology works, and if it does, is there a market for it? Is this the right time for this advance? And how can we help these things get off the ground really quickly? And then ideally, these things go off and graduate and become standalone companies or parts of Google. So things that we've done before at X, we had this life sciences group that would work on contact lenses that would flash in your eyes when your blood sugar was low for diabetics. We've worked on things like indoor mapping, machine learning that we sent back out to the rest of Google. So with that broad introduction aside, I spend my time working on civil aviation issues, both in the US and abroad. I work on a bunch of different things. If it flies at Google, pretty much I've touched it at some point. I work on things like Project Loon, which is high altitude balloons for providing internet access. I work on things like Project Wing, which are small UAVs for basically delivering stuff to you. High altitude UAVs for, again, internet access, very similar to the Facebook concept. Airborne wind turbines. So it's a lot, you know, I'm really boring at movies, at sci-fi movies, because I'll sit here and watch Big Hero 6. I'm like, that's a Part 77 obstruction where the hero's flying around. So, but that's kind of my role. I get to hop around from these different projects. You know, largely, like, kind of where I fit in here is, you know, civil aviation in the US is a, like, single agency. Thank you, supremacy clause of the Constitution. The feds regulate it. I have no states like in the financial market. That said, I exist kind of, my project exist on like the margins of the last page of their regulations. You know, largely their regulations are designed for, I know a number of you are from out of state, commercial aviation, right? Commercial air carriers, like common carriers, carrying the general public for compensation. And so the FAA has a huge book of regulations designed if you're, you know, the safety levels differ based on what you're doing. If you're carrying the general public for compensation, you have to follow Part 121. If you're carrying cargo for compensation, there's a different section. If you're doing on demand, there's yet another section. But it's all tuned for kind of existing businesses, kind of for the incumbents, which is generally commercial aviation, civil aviation, and the military. My projects kind of exist, they're like kites and balloons and gliders. And so, you know, rather than have like these, you know, there's huge sections of the US, the CFR for airworthiness, equipment certification, operator and operation certification. I don't have any of that. I have like, you know, either my regulations are about 3 pages long or they don't yet exist. So I'm always in the struggle of trying to figure out ways of helping innovators find ways of testing their ideas in the absence of enabling regulation. Just a couple notes on the FAA. It's an interesting one as a regulatory body because not only does it set regulations and policy, but it actually also operates the air traffic control towers. So there's a part of the FAA that has to basically police itself. And then within this kind of network of operations, you know, those oversee my group's operations. So it's a very complex being. I will get often contradictory answers from regional offices versus the DC headquarters, and I'll have to kind of like make our, you know, basically assess risk and figure out which one's right and try to kind of take the risk out of this ambiguity that's presented. In comparison to the FDA and the NRC, like the FAA's regulations is shockingly simple for what it involves. I mean, it's resulted in a fairly safe civil aviation environment, but you know, for the first several decades, they relied on this big sky theory, which is not that complicated. The barriers to flying are pretty high. You have to have a plane, you have to be a pilot, and to be flipped, it's a big sky, right? You can run general aviation around, and there's a lot of room up there. There's not that many general aviators up there. 2 quotes to give you this in context. You know, I often thought about getting a pilot's license, and you know, I asked my engineer friends, like, hey, how much does it cost to fly? And it's like, if you have to ask, you shouldn't. You don't want to pay for it. The other quote is, you know, the easiest way to become a millionaire in the aviation industry, in the airline industry, is start with $1 billion. You just lose your way to it. So, you know, the FAA kind of, you know, for emerging entrants like me, they find themselves in this weird place of having to, you know, administer this shared commons of the national airspace and provide for, you know, the entrenched incumbents, big air carriers, military, general aviation. The modelers, which are an amazingly powerful lobby in this country. If you fly a model aircraft, you have a very powerful lobbying body behind you in the United States Congress. And then there's folks like the emerging entrants. And this is a weird time for us. There are a bunch of emerging technologies in aviation, like Project Loon for balloons. The drones are the ones that are all over the news, but commercial spaceflight is really kind of taking off, and the other Mike will kind of speak more towards that. And they're always in this tension of trying to assure safety while letting planes land at SFO, and also simultaneously finding ways for innovators just to do stuff. You know, half the time I find that, you know, my engineers will complain, oh, the regulations won't let me do this. And I know that the technology is not yet ready for it, but in order to validate that, you have to go out and try. So the way I've kind of advise my new projects is to find ways of taking advantage of test authorizations like the research use only, kind of similar things like that in the FAA. You have exemption processes that will allow for that sort of thing, and kind of segregate yourself. Put nice big operational barriers so that you don't have to rely on what your engineers or your operations people think they can do. You still have you built in structural restrictions to kind of ensure safety. And with that, you can kind of start gathering data, and then you can learn from there, and then you can make it a conversation with the regulators. My parting thought is, the way I approach, civil aviation regulators around the world, they're not, they sound similar to like nuclear regulators. It's an entrenched industry. They've been around for, forever, decades. When I approach them with a new idea, I just ask them, hey, let's just take the timelines out of it. Let's take the technologies out of it. I want to do this concept. Let's just whiteboard and clean sheet a design of how we might get there. Tell us what's important to you in terms of safety. For me, it's often the transponder, certification, that sort of thing. And then let's, I don't have a whole lot of details, but that means I'm early on in my design process. That means I can build in a lot of the things that are important to them. And, we'll kind of, try to figure out timelines, and, they're thinking maybe decades, I'm thinking maybe 5 years. But you can come together and kind of, address their concerns, and, hopefully do some, open up these regulated industries for some freshly needed blood.
I'm the Director of Launch and Regulatory Affairs, so in addition to going out and doing all the regulatory things, I also go out and get the launches for the satellites, so the pieces that are necessary to get the mission going other than building the actual satellites. So what do we do? The whole idea behind Planet is to image the entire Earth every day and then make that change visible, accessible, and actionable. So if you look at the average satellite image on Google Maps or Google Earth, a lot of that is either from airplanes or it's from high resolution satellites, but it's only in very specific areas. So if you look at the freshness of a satellite imagery across the entire globe, it's about 1 to 3 years old. There's certain areas that are updated more often than that, but if you look at the entire Earth, it's 1 to 3 years old. That's what's available to folks like me and you. Other government agencies, intelligence agencies, things like that have more access to imagery, but this is what we're talking about for the average farmer, for the average consumer, things like that. And when we talk about innovation or doing things differently, the way that we're enabling imagery of the entire Earth every day is to look at satellites in a different way than is typically done in traditional aerospace. So you have a picture of, this is to scale. So NASA's, a typical Earth imaging satellite that NASA would build or contract to get built is Landsat 8. And these are like billion-dollar projects, and they launch one every, let's say, 5 to 10 years. And they're very sophisticated machines. They're able to do certain things that our satellites can't, but because they're so expensive, because they're so complicated, you launch about one every 5 to 10 years. Our satellites, they're called Dove satellites, and it's about the size of a loaf of bread. So what we do is we build these very small satellites, and we build lots of them. So we're building them in serial production, we're building them in volume, so we can actually launch a fleet of about 120 of them, which is necessary to then scan the Earth every single day. So we're getting a picture of every spot on the Earth every 24 hours with a whole fleet of those things because of the size and because of how we're building them, we can build and launch lots of them and capture the Earth in a way that you can't really do with the bigger satellites. So to date, we've launched over 100 satellites. We have about 50 operating in orbit right now. And again, to get to our full capability of imaging the entire Earth every day, we need to get to 120 operating. So in the next 12 months, we'll have the full fleet. And so it's actually pretty cool what you can do with relatively small satellites, the imagery that you're able to capture. So this is a series of imagery that we took in Cape Town, South Africa. And so I'm going to scroll through a couple of days of imagery, and I'll go back and forth. But there's certain things that you can see, and you don't need the best resolution, but with global coverage, you're seeing change every day. So you can see how ships are moving in and out of a port. You can see if new buildings are going up. You can see if roads are still available. And this is something that's being done on a daily basis. So there's a lot of different applications that can come out of that. Agriculture is another really big one. So this is an image we took in January, and then just a few short months later, you can see that the sugarcane was harvested in this particular agricultural field. So where some satellite systems will go for very high resolution, so these very big, monstrous, kind of expensive things, we go for a bit more of a medium resolution, but it's a monitoring, and that allows us to see a lot of different things on the planet which you wouldn't otherwise be able to see. So with that comes the regulatory environment, and another theme that we've heard from the panel is that sometimes you come into a regulatory environment with a relatively new idea. It kind of looks like the older systems, but in a lot of ways you're trying to fit a square peg into a round hole, and it can be really challenging to figure out what are the licensing regimes that you have to go under, what are the rules that apply to you, how does that relate to the incumbents who are already operating in space, who have very little interest in allowing you to come into the industry. And so a bit about my background. I'm not a lawyer. My background is in aerospace engineering. I also got a master's in space studies at the International Space University. But it's okay, because a lot of these regulations come from the CFR, from the Code of Federal Regulations, and it is human readable. I can attest to that. So you can actually just look up the sections in the CFR that are relevant to you, and then if you have questions, talk to a lawyer. But you can get most of the way there just by reading what's in the CFR, at least for understanding the regulatory context. But I think that everyone on the panel would agree, not only understanding the regulatory context, but also developing like the person-to-person relationships with your regulators makes a huge difference. Because if you come in as a new idea, as a new startup, and you submit your application, you're just a piece of paper, and they don't really care about you because they get pieces of paper all the time. But when you're an actual person sitting in front of them and you say, I can image the entire Earth every day, do you want to help? Right? Then they'll be like, okay, we can figure this out, right? So there's different parts of the satellite environment that need to be regulated. So one of the biggest parts is the radio frequency licensing. We're transmitting our imagery down over radio waves. They're being collected at ground stations, and there's different regimes that we have to adhere to. So in the international level, there's something called the ITU, the International Telecommunications Union. So that's kind of like a UN body that regulates radio spectrum. And then here in the US, there's the FCC. And then there's a lot of coordination that happens with other government agencies that are also using radio spectrum, other commercial operators who are operating satellites where you have to share a spectrum with, or you want to make sure you don't interfere with them. And so it's access to this radio spectrum. Interference is a huge deal, and it's one of those things where it's a public common. So you need to have some form of a system that doles out permission to say, okay, Wi-Fi is going to be at 2.4 gigahertz, and cell phones are going to be 500 megahertz away, so they're not interfering. The spectrum band plan is a pretty crazy quilt's work of trying to let everyone have enough spectrum so that they can do their wireless applications without jamming everyone around them. And then also, sometimes a regulatory body will take on responsibilities that might not even make sense, that they are the ones that are doing that, but it just kind of happens by accident. So the FCC is also involved in giving us launch authorization and also orbital debris. So like Mike was saying about the big sky theory in terms of airplanes, there's also that going on in space too, that space is big, but collisions can happen, and so you have to be very careful about what debris, what junk you're leaving out in space. If you're in a similar orbit to someone else, is there a potential for collision there? All that stuff the FCC is taking a very close look at. For the actual satellite imagery that's being captured, that's under a NOAA administration, and so they're also coordinating with other U.S. government agencies, and especially intelligence agencies, because it was only since the 90s that commercial companies could even launch satellite imagery. For a long time, governments thought that it's crazy to let a company have this information because information is so valuable, right? It's pretty crazy that a company in San Francisco can image a place in North Korea, and we can understand like what's going on with how their trucks are moving on a day-to-day basis, or maybe even the U.S. government doesn't know that yet, right? Or maybe even the North Koreans don't know that yet. So it's how we collect the imagery, who we sell that imagery to. They take a look at that, and there's certain restrictions on how fine of a resolution you can get to, what spectral bands you can use, access to foreign nationals, because a lot of this is based on national security policy, and different security measures that you have in your facilities to make sure that where you store your imagery isn't being accessed by people who are hacking into your system, that kind of stuff. And finally, another big one, which was already mentioned today, is export control. So the Department of State with ITAR and Department of Commerce with EAR, the satellites are controlled technologies. So for a long time, all satellites were on the ITAR. More recently, some satellites moved to the EAR, so we're under that now. So it's a less stringent regulatory environment, but it's still a lot to comply with. And this involves things like the actual technology that we're building, the physical hardware, IT systems, things like that. So those are the three main areas that I work on this satellite project. And like I said, not coming from a lawyer background, it is possible to become like very proficient in the regulatory world, and it's both reading the rules and also a lot of times there's publicly available content, so you can see someone else who did something very similar, their application is publicly available. You go and look at that, and you can even use that as a template to start for your own application. And then also it's the relationship that you develop with the regulators, which is like super important. If you have one person whose only job is to like go to DC every month and shake hands and show some PowerPoints and figure it out, like that, that's a super important part of the process, because otherwise you're just a piece of paper and no one cares.
In the nuclear world, we're all very aware that it's really hard to do any sort of experimentation without very clearly thinking about the potential consequences. So I'm wondering, how do you deal with, obviously, like when you're dealing with blood or when you're dealing with human beings, there are real consequences. So how do we deal with the Wild West while balancing the potential health impacts of your research?
I can take the first stab at it.
All right.
Wild West. I have one example. The first example where we had a brush with a regulatory sort of entity was the DEA, the Drug Enforcement Agency. We wanted to buy human growth hormone and testosterone to feed our cancer cells. And it turns out you couldn't just go out and buy this stuff, partially because the law had changed, and because of the doping era in sports, these were now regulated, and we had to actually go through the DEA and get proper certification paperwork. And when we started this process, we realized it's going to take 6 to 9 months for them to approve our application. And I've used human growth hormone, not personally, but on cells previously. And to get around the issue, we found out that you could buy this stuff through sort of this black market. You could also use animal-based testosterone. And we thought, hey, we're scientists. We know that molecularly they're very similar, and we could start using these things until we get the certification. And so that sort of is sort of a way around the issue. Now, with respect to safety, I think what you guys are doing is of paramount importance. When we're dealing with blood, especially blood samples that may contain viruses like HIV positive, we know how to sort of control these things because we've worked with them in the past. You do need certain safety standards in order to take these blood samples. But internally, we know that, hey, we know it's okay. There's a lot of rules and laws placed just so that you're absolutely sure that you're safe. But the truth is, we kind of look the other way. As long as we know that we're not really jeopardizing the safety of us as well as other folks in the lab, we kind of look the other way. That's kind of the truth. And then my business partner would kill me if he heard this, but we literally would just find ways around existing laws. That's kind of, again, what I mean by the Wild Wild West. You do something and you apologize later. If you look at Uber, when they first started, it's like, how is this legal, right? And what about all the taxi medallions? But there's a way of getting around these issues. Now, with respect to the nuclear energy space, I'm sure it's very heavily regulated, but I'm sure there are other aspects of the technology development that may be not as risky that you guys can invest time in. So I think the moral is that you guys are probably in the best position to just make the judgment yourself. And a lot of the rules, we look at it as being inhibitory, right? We're more rule breakers than rule followers, which is the reason why we're doing what we're doing. But again, that's an individual decision. But again, that's something that we're constantly faced with as we grow and as we become sort of legit.
I would say that the financial services industry is not the Wild West. Uber would not work in financial services. And I think one of the big differences is that the industry, and maybe weirdly like the nuclear industry, is they're seen as a really significant social, the government has a really strong reason to be involved in protecting not just institutional structures like the money system and preventing people from funneling money to terrorism and things like that, which those just like that alone creates a whole cascade of regulations that affect global financial services more broadly. But even on a very specific level, just preventing people from getting their money stolen from them. Of saying I'm a bank when in fact I'm not a bank is the reason for entire federal agencies. And so when you do things like part of what we're looking at is really early stage startups, like you need to get something going, you need some sort of product, and there is a threshold of in any kind of industry where you have potentially have investors, you need to find out how to figure out if get a proof of concept on the cheap. You can't get everything perfect. There's probably not many startups who are going to be doing even space exploration. There's something they did initially to demonstrate that there's some reason that investors can get their money back. And I think in financial services the same way, I'm assuming nuclear industry is the same. You got to do something early to test it. But I think in these really complex and regulated industries, you also need to make sure that what you're doing is going to be able to raise money at later stages. We see a lot of ideas, we're wow, that's great, that's awesome. You can probably find a couple angel investors or maybe some kind of naive institutional investor to give you money for that, but can you realistically raise $100 million or $500 million? No. And that's the threshold, and I think that if you're going into an industry where it requires that much capital, then you need to have some awareness of what those trade-offs are as a business grow.
Every time I make that argument to my guys, they point at Theranos, and then look at those nice offices on Sand Hill. Those don't pay for itself. Look at those multiple rounds of financing. But aviation, and not just at Google, but right now is in this period as an industry of being the Wild West. Anyone, say you don't go hiking tomorrow and you get $800 and you're near a Fry's, you can buy a drone and become part of the drone community. You can fly near 3, depending on how you count, airports within the 5-mile cone and cause a risk to air traffic, or nothing will happen. Who knows? And I wanted to turn back to this notion of risk, right? As an industry, because of the lack of enabling regulations, what we're hobbyists, if you're as an individual, you can go out right now and, like I said, fly a drone, and that's because all the FAA has is this 80s era kind of kid in a park guidance that said, hey, just stay away from airports, fly in clear weather, and just fly an RC plane around. And they never expected it would, it was written for basically the stuff you buy at Toys R Us for like $40 or 20 these days. And, as an industry, the first time one of these things actually hits a commercial airliner, that's done, right? That entire industry will go on hiatus or possibly even worse because of that risk to air safety. And that's the kind of, finally we have some enabling regulation that will come online at the end of this month in the US that will introduce some order to this. But right now, when you see plane or little drones flying around near an airport, that's because perversely, to try to create this enabling regulation, we've gone for essentially a decade and a half without it. And so the room for, to build these kind of commercial operations that will take funding, that you can build real businesses that you can employ people with and they can, raise their families on, just haven't had room. Now with this enabling regulation, I think the venture money is going to come flooding into the drone market. And so that's kind of one of the advantages of having these kind of things. But that's the risk that you take when in running the Wild West. You can get shot in the Wild West, no one would know, and your body would lay there, right? And so that could happen to your idea, your company. Yeah.
Well, yeah. One thing I wanted to say is you could find yourself in a place where there isn't clear regulation or how that applies to your specific idea. But just because you can do something doesn't mean you should. And I think that like it was said earlier, you might actually have the best idea of how to do this safely or responsibly. And if you're doing something new, it's likely that you might actually become the driving force to create the new regulation or to pave the way for something so that regulators actually feel comfortable for accepting this because you've shown how responsible and thoughtful you've been throughout this kind of gray zone process. So I think that regulations are not there just to make your life hard. There was some public safety or some intent behind them that was for the general benefit. So if you keep that hat on when you're trying to do your new thing in an unregulated way, I think it ends up greatly benefiting you in the long run, so that you can actually shape the regulations and they'll be sane, rather than if you're just doing some crazy stuff and then someone finds out and they shut you down, or the regulations come out and they're way over complicated and over strict than they need to be because you weren't part of the conversation early on.
Can you explain a little bit, since this is like a newer, place to do this kind of, this is a new thing, what kind of considerations there were for you explained radio frequency, satellite imagery, and export control, but did those regulators consider the farther reaching regulatory concerns?
Right. I think I understand the question. The short answer is no. But this isn't an area where we started from the beginning, where we made it very clear that our mission was to use space to help life on Earth, and that we wanted to use this technology for the benefit of the planet, so we can take better care of our planet, so we can see deforestation happening, so we can increase agricultural yields, especially in developing nations, things like that. So we made it a part of our mission statement, and we were very open about that. Like any technology, it can be used for nefarious purposes. And there's certain things that we've already baked into how we do business that will prevent some of that. So we will never provide imagery in support of direct military conflict. But there's still going to be ways that people can misuse this imagery. Just like the internet, there's all kinds of ways that bad things are happening on the internet, but on whole, the net is very, very positive, right? So I think that it's from the beginning, making sure that what the applications you're driving towards are positive, and then also that being that part of the message. So even though there will be some bad things happening, the overall overwhelming use cases will be for good.
How do we go about the financing part of going through the whole regulation assessment? Is it Planet who wants, because we're partners, do we go 50-50 on how much time and money is it going to take for us to push this through? Or is it just me, or is it in the interest of Planet? Because we're doing a hydrogen-based company producing hydrogen from a nuclear power plant. So we don't know exactly if how much money we have to put into that to the NRC, or if it's the utilities who buys our license for the hydrogen, producing part. So I just kind of, this general question for all of you and, for the finances as well. I don't know if you guys have any input on that.
Just the answer financing piece is just like, you got to it's a negotiation. I have no idea. I don't understand what the seminar is, they're putting out the thing. But if you need the satellites, you're probably in an inferior position in negotiation with him. So you probably, depending on where you are as you're thinking about raising, this the question is really about raising capital and negotiating a partnership. You have to be realistic about where you are in that cycle versus your counterpart, and what you really need to achieve. You probably don't need a global agreement with Planet Labs to get you maybe to the next stage. Maybe you just need to test something to say, hey, this will actually make it up into the atmosphere and still work. You might be probably, if that's your only opportunity to get into space, they're probably going to drive your negotiation. And I think one mistake a lot of early stage entrepreneurs make, across any field, I think, is to assume that there's a lot of value in an idea, and also to overplay their hand a little bit. Realistically, these guys have a business model. Google has a business model. He's got a business model. And so if you're going to somebody else and saying, hey, look what I'm doing, it's so great, you need to make that align with their business model, and it's more critical that you do it. And so a lot of things early stage companies do have fighting over small amounts of equity, or the price of an investment, or revenue share. If you're an early stage company, you're way better off just taking a deal you can do and go doing it. The guys from Box, for example, when Box, they went public a couple earlier, last year, I think. And there was a lot of criticism that the CEO, he only had 5% of the equity left in the company. He had 5% of the equity of a $1 billion company. And so, if he got really greedy early on, would he have been there? Probably not. And so that would be just from a finance, from the investor perspective, to keep in mind.
Obviously, the regulatory industries that you're in are different, and they're all also different from the NRC. But one thing I'm curious about, rather than how open is your regulator or regulators, is, we in the nuclear industry, we often think of the nuclear regulator as a constraint that's in our way. But I think it's obvious from the different industries that you're all involved in that the regulator shapes how people think and how they innovate in that industry. It's those constraints that inform your design. So, the staged process of the FDA, the open sort of wild, wild west of the FAA or space. I'm interested if you could each say something to how you think that the regulator actually inspires innovation as opposed to constricts it.
Well, I think lack of regulation, I think is generally good for innovation. That's assuming that safety is maintained. And I think if we didn't have this sort of RUO, research use only category, I would imagine that a lot of companies, including Theranos, would not have had the opportunity to raise financing and really inspire people to maybe say, hey, maybe we can create something that hasn't been developed before. And the same thing with the FAA. I think it's just seeing a lot of drones fly around. That inspires, the creative-minded folks to think beyond just the commercial airline industry and to come up with innovative new ideas. And so I think, at least in medicine and the biotech sector, I think the DEA, the FDA, all these entities realize this, that maybe what worked 50 years ago isn't really conducive, especially in terms of commercializing innovative ideas. And surprisingly enough, they're willing to work with you, right? They're people like yourselves. They're inspired by great ideas. But I sort of think if you have a compelling piece of technology, right, and it really is going to benefit people, right, the regulatory hurdles will disappear. Whether it's through lawyers, right, or whether through changes in laws, it will disappear. right? And so our investors, early investors, like, well, don't worry about CLIA, don't worry about the FDA, just focus on your technology, make it compelling enough, right, where they can't say no.
Yeah, I mean, you know, when you're in an industry where there already is regulation, you know, you kind of got to deal with that. You got to keep in mind it's a double-edged sword. And like someone, I think, you know, Mike made the point that, you know, these are people working in these organizations, and you know, they just got a job they're trying to do, and to a degree, it is very helpful if you can go in and say, hey, I know your primary concern here is safety and soundness, and I'm working to solve that problem. This is what my thing does. There are very few entrepreneurs like in the financial services that approach regulators and say those kind of things. And then there are organizations like Wells Fargo or JP Morgan that have armies of people that are in the regulator talking to these people what they're doing on a day-to-day basis. And I'm imagining in the nuclear industry, it's probably the same way. Something tells me General Electric has a pretty good pulse of what's going on. And so when you can show up and say, hey, this is what I'm going to do, this is how it fits into what your goals are, and this is, I'm a good actor. I think the Theranos, I mean, one thing about Theranos is worth keeping in mind is like, there was either fraud or an ineffective product at the root of that. And so if there wasn't something wrong, then the Wall Street Journal wouldn't be writing stories about it, and the company wouldn't be collapsing, and the FA and the primary regulator wouldn't be in there like censuring them and kicking the founder out. Like, those are extreme things that indicate a much deeper problem. If you're out in front and you're talking and you have good intentions and you're being transparent and honest and working with the regulator, I think generally as certain financial services, you're way better off than not.
Yeah, I wanted to echo that point about relationship, and you know, bureaucracies are, you know, it's easy to like cast it as like this impediment, but that means you've got a big organization that you can work, right? You know, GE, there's a reason GE invests in those people to work the halls, because you can find people who are thinking about the structural ceiling of their existing infrastructure, looking for ways of breaking apart kind of what works today, but because they know it's not going to work 10 years from now. Like in the FAA, in aviation generally, this trend towards automation, of removing the pilot and a human out of the loop. That's one of the holy grails of making the big sky theory work and for keeping, you know, our antiquated air traffic control system working. But that's not going to scale to grow. That doesn't enable, you know, twice the amount of operations that we have today, much less the 100x that the drones will bring. And so you got to find people who will listen to you and then build relationships with them and then sell the positive benefit. Because look, the easiest way of avoiding risk in aviation is just to ground. Don't do anything, just, you know, do something else, right? But there's a trade-off. You can get some societal benefit of mobility, encouraging trade, and that's really what you've got to sell. And you know, there are tons of technologies, but you've got to show a good social end. And you know, at the end of the day, the FAA is a political, it is a subject to political oversight. You've got to find, it's not going to be easy, but you've got to find those people and give them a message that they can kind of work around. And you know, for us, you know, Loon does a tremendous amount of international operations. If you can get over that hurdle, that the table stakes to sit down and work in this industry, FAA approval or your regulator approval will help you open doors in other international markets, which is, it's a long-term play, but it's something that can help you grow really quickly.
I think there are lots of cases where there's specific regulations that actually force technology innovations. So for instance, you know, with radio spectrum, it's such a crowded space, maybe you would want 100 megahertz, they only give you 10, and then what happens is you actually get really good at using those 10 megahertz. So whereas, you know, 50 years ago we had amplitude modulated technology, now we can get, you know, 10, 100, 1,000 times more information in the same, you know, RF pipe, just because that constraint was implemented. Or even for, you know, for satellites, there's a limit to how much time you can spend in orbit before you have to come down. But they don't tell you how you can do it. So a constraint without a prescription on how to fulfill that constraint actually does breed a lot of innovation, which can end up as actual like real technology that can be applied to lots of different places.
Okay, so first let's get a ballpark timeline and cost, capital cost of bringing an idea to market.
Yeah, well, okay, I mean, for licensing, it's typically 1 year, 1 to 2 years. But And then depending on, so there's experimental things that you can do, like we talked about, that are, the costs are less than $100. And then when you get to an actual commercial thing, it's more like $500,000. So there's a big jump in terms of what you need to pay to actually become fully operational.
Aviation really depends on what you want to do. It can be 6 months to 10 years, depending if you need to change regulations, you're looking at 10 years. Costs kind of run the gamut. For example, I always get asked these things. I want to do an Uber for airplanes. Turns out you can do that right now. There's enabling regulation under Part 135 for air taxis. You'll go broke easily in probably 60 days doing it, but the regulations are not an impediment. It's really market and operational costs.
I would say the same thing in financial services. It really depends what you're doing, how much capital you have. I will say the second half of your question, 20 years, that's probably not a good idea for us if you're like not a massive corporation or a state. Like that's beyond any investor's time horizon except for maybe like an insurance company.
Well, so the reason that she's asking is 10 to 20 years is the average licensing path timeline in nuclear.
Then you need to figure out unless there's a cadre of investor, like unless the government invests in these on your behalf, that is outside of any private sector. So give you a sense, venture capitalists typically need return capital in 10 years. That's what they're targeting to do. And so if you go to a venture capitalist and say, this will take 20 years, you better have a way that they get their money back in 10. And that's just one of those kind of things to think about, like within the construct of financing, kind of how that works.
Yeah, absolutely depends on your technology, the product you're trying to develop. In terms of licensing, it depends, but I think I can echo the points here that 20 years is probably prohibitive. If you can come up with an idea that maybe will shorten that time frame, maybe that's worth pursuing.
I can give you like an example in finance. So like banking, like there's a lot of people who are like, I want to start a brand new bank. They have not gotten, hasn't been a new bank charter. There's been like one or two for the last several years. And just looking at your faces, none of you would get a bank charter because you're not old enough. You don't have enough bank experience. Literally, I wouldn't either. No one in this room would. And so there are these barriers which seem like, well, I can't start a bank because I haven't had 30 years of bank experience. And the regulator is not releasing new bank charters. But that doesn't mean there's not innovation. There's a ton of innovation precisely because of that limitation. Kind of going to the point about like, sometimes the regulatory structure creates opportunities just in the fact that it is so rigid. So I would think about your ideas in a sense of working against a rigid system rather than trying to change.
Yeah, and sometimes there's ways where you can kind of future-proof your applications a little bit. I don't know how applicable this would be in your case, but for instance, if we're trying to decide, we have to make a decision today what we're going to put in the application for something that's going to happen 1 to 2 years from now. We don't know, is it going to be 10 satellites or 20? Just put 20. It's always easier to go down, right? Whereas you're up against the deadline and you say, oh, actually, I put 10, but we actually need 20. That's way harder. So you can add a little bit of margin in kind of future-proofing your applications to whatever extent is applicable in your specific scenarios.
To the point about investors, I would add, like, you want to look for kind of, if you really looking at a 20-year timeline, you've got to break that up into milestones to show achievable progress that will, satisfy your investors and also, challenge your engineering team to kind of, and it probably won't be full on operations. It'll be some kind of core component. You'll look for different aspects of it and look for things that don't require that heavyweight 20-year process, things that you can authorize under one of these lightweight kind of experimental or research exemptions, or potentially look for countries that would allow you to do that. And then to the point about, private industry versus government, at 20 years you do really want to look for government partners that might be interested in this, who can help you kind of give you some stability through as you walk through these milestones.
And just, just to give, to kind of follow, like Google, one way also to think about it is find a partner who could really benefit from that. Like if you can, go into this kind of staging, if there's some sort, like, let's say you're 20 years away from fusion power, you know how to do this, right? Maybe there's a milestone like 5 years where you can go to Google and say, I found this thing, and then they're like, wow, that would save us so much money. And so like then they would kind of buy into it. Like, you don't necessarily have to get it to be generating revenue or something, but something where an observer could come in and be like, they've demonstrated something here.
Given the massive and unusual hazard in our industry, some, and just bearing that in mind, some are choosing to go to other regulatory regimes to get first reactors past the post. So 2 questions. Why do you think they're doing that? And what's your opinion of that?
Companies will go in and file in more, in like easier regulatory environments, so like in the Isle of Man or in like the Channel Islands, places where they're clearly not actually doing business, but these are kind of regulatory loopholes. Our company decided not to do that, and partly because we know that no matter if we can solve one problem with that, there's still so much coordination that we have to do with the US government. It's in our best long-term interest to feel like partners rather than we're trying to step around them. And so, you know, I call this like the USA #1 strategy, which is one of the best ways to get your regulator on board is to say, hey, there's another foreign competitor who's doing this and they're about to beat us and they have already gotten their regulatory approval. Are you really going to let the US fall behind on this? Right? And actually, this is a serious thing which people in Washington seriously think about. And so you have to remember that by solving a short-term problem, you can actually make your long-term business at risk, because now the US government's looking at you as not fully on board, right? And so that's just a decision that you have to make on you know, what are the benefits with going to an easier regulatory environment versus not. And if you want to be a US company, my guess, especially in the nuclear industry, is that you want to have a pretty good relationship with the government. If not as a regulator, then as a customer, but it's all kind of tied together.
Your point about the relationship is right. You know, in the aviation industry, the U.S. aviation airspace is probably the most complex in the world. And because of that, they fully recognize there are risks that other countries can take and they simply can't. And so I think when you go to them and explain that, for them, you can potentially like kind of do this jujitsu and turn it into an advantage, where you can say, look, you need data in order to write solid, informed regulations. We can do this in some other country and test without putting your complicated airspace at risk, and then and as long as you're up front and you kind of explain what it is you're doing to this point about relationships, I think you can look for these areas where you simply, like in aviation, you know, the safety risks are largely start from arithmetic, population density, number of aircraft. And if you go to a place like Australia or New Zealand, where you either have an uninhabited outback or like literally several thousand miles of the South Pacific where there is nothing, no traffic, no shipping, you know, you can create a safety case for something that you could never do in the United States.
I mean, the biotech medicine space, it's sad, but it's true. We do a lot of our testing in developing nations, and so they get a chance without sort of government oversight whether or not drug works or it's toxic to the individual. Happens all the time. It's just not reported. Us as a diagnostic company, if we do our studies in China or India, it'd be 1/10 of the cost that it would cost to do it in the U.S. Morally, I'm opposed, but financially, for a startup company, those are compelling sort of value propositions, if you will. Now, that being said, it seems like you guys are all interested in maybe creating a next-gen nuclear reactor. But I think there are so many different things so many different areas that maybe doesn't necessarily have to involve the reactor that you guys can innovate and start companies on. I know nuclear waste or disposal of nuclear waste is something that is becoming a huge problem. So I mean, if you were able to sort of propose something where, hey, I'm going to strap nuclear waste to rockets and send it to the sun, right? I mean, you'll probably get some Silicon Valley investors happy. But there's so many different things that you could do. And so I think maybe tackling the big problem of creating nuclear reactors is maybe short-sighted, because again, there's ample opportunity to create value. And again, I think we mentioned having an outside partner place value on your idea is probably the biggest validation that an investor would like to see. That would ultimately decide whether or not they would invest in your technology or your company.
Yeah, I think you're probably mostly all engineers. I mean, you think like when you have startups, oftentimes there'll be like engineering debt that they've made shortcuts in building this product. They have to go back and fill in. And as you know, as an investor, as a founder, you want to be aware of what that is, because you get to a certain scale and things break. And if that's it, you just took $1 billion, like you broke in a really big way. You're a public company, it's a disaster. And regulation's the same way. Like you see, there's a lot of regulatory arbitrage, is basically describing. It's super common in financial services. You just got to keep in mind that you could be building up a pretty significant regulatory debt. And if you'd start building something and it works really well in the Isle of Man, and the U.S., the Justice Department thinks you're facilitating money laundering, like you probably haven't built something that valuable. And that's, I think, I don't know if that applies, and I'm assuming it might apply in nuclear engineering too. Like you get something that works in Iran, which probably doesn't have a lot of value outside of it. And so that I think is worth kind of balancing that as you're going through this process of knowing where you're making trade-offs. As like a financial institution, you're expected to be kind of regulating yourself in a way, generally, all the time. And so for the most part, the regulators are unless you're like I think they're probably like the nuclear industry, like at a certain scale, like the regulator will literally sit there in the institution. So most larger banks, there's an examiner who's on site. Maybe in the case of a giant institution, hundreds of them. And for earlier stage ones, you're expected to abide by all the same laws. And so, like if the regulator shows up, or your partners, a lot of times the startups you see as our counterparty will require it. So SoFi, not a regulated, mostly not a regulated entity, but like they're selling loans to a regulated entity. The regulated entity is going to basically, through kind of their third party management of it, bring them under their regulatory umbrella and require a lot of the same requirements that they do as well. And then you'll see in specialized industries, you'll have lobbying groups, you'll have advocates like in financial services, Google and Intuit, Apple are part of the big technology companies are part of one group in Washington that has their own agenda that they want to talk about, and they'll have their own standards that they'll set around data privacy and data security that maybe the banks aren't necessarily in agreement on, but they may say, well, ours is better. And so you'll see some of that kind of stuff happening as well.
I'd also say that at the end of the day, the regulatory risks are the bare minimum of what you should be able to get by. I mean, if for any of these products that you're talking about several $100 million, if not more, millions of dollars at risk. And so there's a whole variety of kind of things that you need to do just to stay safe and protect your investment, protect your investors' money. And that's kind of, as the lawyer, that's kind of my job of managing risk and making sure that these kinds of things are escalated. And so there's an inherent kind of self-regulation that comes with the fact that, we are working in kind of these very specialized fields that require a lot of money to go in.
Thank you guys so much for joining us. I think that this was really informative for everybody, so go ahead.